Hello, everybody. How you doing? I'm here today to talk about planning an experiment and primarily about variables, and I'm going to do it with a classic example of growing tomatoes. So let me start with our vocabulary. Um, there are four words you need to know when we talk about variables. The first one is the independent variable, and it's the thing I'm changing in my experiment. Whatever it is that I want to know about my experiment, this is the thing that I'm going to change in each iteration of my experiment. I've also got a dependent variable. A dependent variable is the thing I'm going to measure. If I want to change the independent variable in each experiment, how will I know whether or not it worked or what result came out of that experiment? The dependent variable is the thing I'm going to measure, the thing I'm going to use to determine how each independent variable performed. Um, those two words, independent. Independent means to stand on your own. If you pay your own bills and live in your own house and have a job to collect money somehow and generally take care of yourself, you're independent. Or if you like to work on your own in your schoolwork, that's independent. Dependent means that you like to or that you are dependent on someone else. Someone else is going to help carry you. Maybe someone else pays for your rent, and so you live in someone else's house, or they buy groceries for you, or they otherwise provide for your care. And even no matter how independent you are also dependent on many other people. I am dependent on the mailman to drop off my mail, and I am dependent on the you know the Department of Transportation to keep the roads clear. So we're all dependent on one another in one way or another. But for the purposes of my experiment, the independent variable is the thing that stands alone. It's the thing I'm going to change from each iteration of the experiment. And the dependent depends on the independent variable. It's the thing that's going to change based on the changes I made to the experiment. There are many constants in my experiment. These are all the things that I keep the same in every version of my experiment, so that in test 1 and test 2 and test 3, I'm changing the independent variable in each one. Everything else is going to remain the same about that experiment. And then finally, the control. A control is a copy of the experiment without the independent variable. Maybe you've heard of a placebo. So they are trying a new medicine and they give everybody a dose. Half the people get the real medicine, half the people get a sugar pill called a placebo. And then you see if there's any difference. If both groups respond the same, well, then we know that that medicine really didn't work because the people who got the placebo worked the same, had the same results. Hopefully, if that's all confusing, this will make sense in a minute. We're going to try it out with my example about tomatoes. I love tomatoes. They're easy to grow, and they're way more delicious right off the vine in your backyard. You don't need a lot of land. You can just use a flower pot. They're a great plant to grow. They only take a little while to start, too. They take about 20 to 30 days to start to mature, and then another 20 days or so to grow. So within 40 to 50 days, you can get tomatoes that you can eat yourself that are delicious. So I'm going to decide what kind of fertilizer I want to use to make my tomatoes grow faster. I got 3 options I'm going to test, and I should take a moment to say that I know nothing about these particular brands. I made up all my numbers. I'm sure they all work great. I'm not actually making any real data here. I put all this together an hour ago. So I'm going to try these 3 options out, though. They seem to be the best sellers online. Scott's Flower and Vegetable, Miracle-Gro Garden Feeder, and Nature's Care Organic and Natural Vegetable, Fruit, and Flower Food. So I'm going to use these 3 fertilizers and see which one works best. But even that is kind of a loaded question. How do I know which one works best? Am I talking about the tallest plant? The ones that make the biggest tomatoes? How about the plant that grows the most tomatoes? There's any number of ways I could track this. Which one grows the reddest tomatoes? Which ones taste the best? There's so many ways I could use to grade this, but it's best to have, like, telling me which tomato tastes best is hard to is hard to calculate because what I think tastes good might be different from what you think tastes good. So it's easier to get data on something I can measure quantitatively, something that I can assign a number to, like how many tomatoes did the plant produce. And so that's the one I'm going to use. I will count the tomatoes grown on each plant to determine the best fertilizer. So I'm going to have to grow 3 different tomato plants and feed each one with a different fertilizer. So I've got one plant that I'm going to fertilize with Scott's, one I'll use Miracle-Gro, and one I'll use Nature's Care. I'm going to have to keep these guys separate from each other. So I'm going to grow each one in a separate pot. And I don't want to get a little bit of Miracle-Gro on the Scott's plant. So I'm going to have to separate them a little bit. Each plant's going to go into a separate pot, and they're going to be placed in the same location. So I don't want to put one behind a tree and one on the front porch because those are going to get different amounts of light and water when it rains. I want to make sure they get the same amount of light on each plant and the same amount of water on each plant. They're each going to receive fertilizer according to the instructions on each package. It wouldn't really be fair to just say I'm going to use the same amount of fertilizer on each plant because different fertilizers might have different instructions or different needs. So I want to make sure I follow the instructions on each package. And then after 60 days, I'll count the number of tomatoes that each plant has grown. So I set up a data table. So here's a simple data table. Trial number 1, number 2, and number 3. I've got my Scott's, my Miracle-Gro, and my Nature's Care. And then I'm going to grow 3 plants. And you can see that each plant here has grown a different number of tomatoes. So how do I figure out which fertilizer works best? I'm going to have to count those tomatoes. And when I count these, I've got 5 up front and 5 in the back. And then this one has 14, and this one has 24 tomatoes. So I've added those numbers down here, 10 and 14 and 24. And so, so as I measure these tomatoes, I can count how many there were on each one. So which fertilizer was best? And should I use that one? I really can't say yet. I can look at these and say Nature's Care produced the most tomatoes, but I don't know if any of these fertilizers really worked. Because I need to know if the fertilizer works better than water. Maybe I should just use plain water and I'll get even more tomatoes than adding a fertilizer. I need to make a copy of the experiment without the fertilizer. So we call that a control group. So then I need a 4th group of tomatoes, right? And I would have to have this from the beginning. I can't add it at the end. It has to be in the same location with the same amount of water and the same amount of light. And it needs to have the same amount of time to grow. And it needs to be the same kind of tomato plant. So let's assume I had this control from the beginning. And now my numbers show 10 tomatoes for Scott's, 14 for Miracle-Gro, 24 for Nature's Care, and 14 for the control group. I can assign these names. This fertilizer is the thing I'm changing in each one of my 4 trials here. That's my independent variable. It's the one thing that's changing between each one. The constants are all the other things. Like the plant, right? It's the same kind of tomato. I'm not going to grow beefsteak tomatoes and cherry tomatoes and grape tomatoes and another kind of tomato. I'm going to grow the same kind of tomatoes in each trial. I'm going to give them the same amount of water, the same amount of light. I'm going to use the same soil to grow each one. All those things are going to remain the same. The size of the pot, I'm going to use the same pot. I'm going to water them at the same time of day. Everything else has to be the same. And And the dependent variable is going to be the thing I'm measuring. How do I know which one worked best? And for my purposes, I'm going to say the number of tomatoes. Now, in real research, you might have more than one dependent variable. Maybe I'm going to keep track of the number of tomatoes grown. I'm going to keep track of the number of seeds that are in each tomato. I'm going to keep track of the size of the plant, the number of leaves, the number of flowers. I can keep track of almost any number of dependent variables because the more data I collect, the more I can look for trends. But I can only ever have one independent variable. If you could assume that maybe I changed the amount of water that each plant got, and so these two plants got half the amount of water as these two plants, well, then what changed the number of tomatoes? Was it the amount of water or was it the fertilizer? Okay, I can only ever have one independent variable. Everything else is going to be a constant, and my dependent variable is going to be the number of tomatoes that each plant grew. I need a control group, and the control group is a copy of the experiment that does not have the independent variable in it. So what did I learn? Here's my data table, independent variable and dependent variable, and my control group and my trials and the three of these and my how many tomatoes did it grow. How effective is Scott's fertilizer? Well, it's not effective. It actually harms growth. I had less tomatoes show up than I did with just plain water. And that's why I need a control group. I need to compare each version to my control group. How effective is Miracle-Gro? Should I use it? Well, not really. It's not effective. There's no difference between Miracle-Gro and water, so it has no effect. Even though it produced more tomatoes than Scott's, and you might have originally said Miracle-Gro is more effective than Scott's, well, it's not really effective at all. It's the same as water. So in this case, I can't really say that Miracle-Gro is effective at all. How effective is Nature's Care? Well, I produced 10 more tomatoes with this product than I did with just water. So what should I use? The only product I should use is Nature's Care. Miracle-Gro would be a waste of money because it did nothing for plant growth, and Scott's actually reduced the number of tomatoes by 4. There's always a question that scientists, and especially science teachers, like to ask at the end of an experiment, and you should ask it too. How could I make this experiment better? Every experiment has error in it. Every experiment has something that could be done better, that wasn't quite good enough. More data is always better. What if I grew 5 tomato plants in each category of fertilizer? So 5 with Scott's, 5 with Miracle-Gro, so on and so on. And then maybe I could grow them for a whole season and see how many they produce over the season. I could try other fertilizers, right? I could do Scott's and Miracle-Gro and Nature's Care and 2 or 3 other fertilizers, maybe some compost from a compost heap and a, whatever I could think of, Coca-Cola, like whatever other things I think might make a fertilizer for my plant that I want to measure the effectiveness of. Could I add another variable, like the amount of light that each plant gets? No, there can only be one independent variable. Adding more kinds of the same variable, like adding more fertilizers to my experiment, is okay. But changing another variable, never. No, there can only be one independent variable ever. Period.